Hello everyone, welcome to your episode of Espace News with me, Christophe Paget. This week we shall focus on Blue Origin getting help from SpaceX. The ADITYA-L1 satellite is sending its first data of solar wind. NASA communicates now using laser. The ISS is 25 years old. Starbase is getting its uplift. And ISRO Chandrayaan-3 propulsion module returns finally to Earth orbit, and we shall finish with the launches of the week. On Friday, the board of Amazon won its legal fight with Jeff Bezos regarding the purchase of launch rights from various rocket providers such as Ariane 6, ULA Vulcan Centaur, or, of course, Blue Origin New Glenn, to launch its Kuiper's satellite constellation. The argument from Amazon board members was that SpaceX Falcon 9 would have been cheaper and therefore increased the shareholders' payback. This week, Amazon confirmed that 3 SpaceX launches have been secured in 2025 for the Kuiper's deployment, knowing the battle between Elon Musk's SpaceX and Jeff Bezos' Blue Origin. So in order to compete with SpaceX Starlink, Blue Origin would use SpaceX, which is paradoxical. Well, same happened with OneWeb many months ago. If you remember, in previous episodes, I discussed the ADITYA-L1 satellite located at its Lagrange point L1, hence the name, between the Sun and the Earth. ISRO's ADITYA-L1 satellite has commenced its operations and is performing normally. One of its equipment on board is the Solar Wind Ion Spectrometer, or SWIS. It has successfully measured solar wind ions, primarily protons and alpha particles. Now, the alpha particles are basically 2 helium ionized, so He2+, while the proton is simply ionized hydrogen, so H+. A sample energy histogram acquired over 2 days illustrates the variation in proton and alpha particles counts, as you can see on your screen. The change in the proton and alpha particle number ratio, as observed by SWIS, holds the potential to provide indirect information about the arrival of large clouds of energetic and highly magnetized plasma, also called coronal mass ejections. Now, why is it important to measure and understand this? Is that such a coronal mass ejections are causing radio or magnetic disturbances on Earth. And for example, satellites have been made inoperable because of it, even fell off the sky. Lots of electronic components on Earth have stopped working too. So the measure of alpha to proton ratio is considered as one of the sensitive markers of the passage of interplanetary coronal mass ejections, and hence considered crucial for the space weather studies, and of course, providing an early warning. As researchers delve deeper into the collected data, the international scientific community eagerly awaits the wealth of knowledge that ADITYA-L1 is set to unveil about the enigmatic solar wind and its implication for our planet. Space Shuttle Endeavour launched on December 4th, 1998, the Unity module, America's first piece of the International Space Station, with its mission STS-88. Now, the International Space Station is 25 years old today or this week. I cannot believe it is that old. I remember the first module going up into space with the Space Shuttle. Well, happy birthday, ISS. I might do a dedicated episode one day on the ISS. NASA has also tested its Illuma-T, seen on your screen, by achieving first light, where Illuma-T on the ISS and Laser Communication Relay Demonstration, or LCRD, in low Earth orbit exchange data over laser link. So what the point they are trying to do here at NASA is that there is a communication from the ISS to the LCRD and then to ground base, and vice versa. At Starbase, we could see lots of effort in getting rid of temporary fence around the launch site to be further replaced by concrete walls, as we have seen in previous episodes. The launch mount is continuing to be maintained after the integral flight number 2, and the second mega bay is also progressing with the top level windows being installed, along with the rest of the Star Factory. We can see Booster 10 getting his crown, the so-called hot stage ring, as we have seen in Booster 9. We expect, by the way, that Booster 10 to be the next booster to fly during the integrated flight number 3. Now let us talk about the Indian Space Research Organization, or ISRO for short. If you remember, back in August 23rd, the Chandrayaan-3 spacecraft that you see on the screen on the top left its propulsion module, seen at the bottom of the screen, to successfully land in the south pole of the Moon. The propulsion module carried on orbiting around the Moon for several months to act as a communication relay with ISRO to gather the scientific data created by Chandrayaan-3 and the related instrument. Now please refer to the special edition episode covering this event on the top right corner of your screen. Now sadly, the Chandrayaan-3 electronics and battery did not survive the cold temperature of the Moon, which was expected since ISRO was only focused on getting to the Moon, landing safely, and now returning, all in preparation for sending humans to the Moon. Now this week, ISRO has demonstrated its ability to escape the Moon's gravity and return to Earth orbit to further prepare the human Moon return mission in rather complex maneuvers, I must say, that I am about to explain to you. The propulsion module was orbiting following the green trajectory around the Moon, as you see on your screen. After using its thrusters to accelerate on the right-hand side of the Moon in this particular picture, the spacecraft then will follow an elliptical trajectory. That's what it does when you increase the velocity at a particular point. In this case, we're talking about the purple trajectory, which allows the spacecraft to get further away from the Moon, and then it will do 4 flyby to the Moon to gain some further speed using the Moon's gravity assist, which you see in this picture, which allowed enough speed to get out of the Moon's attractions and becomes earthbound. Although the trajectory relative to the Moon remained an elliptical shape, the trajectory relative to the Earth had the yellow shape or trajectory as you see on your screen. I'm happy to go further explaining in another episode anything further. If you don't understand, just leave me a comment below. The next stage seen in this picture is to get hooked by the Earth's gravitational attraction. And to do so, the craft will have to turn 180 degrees and use its thrusters to reduce this time its speed to correct what would have been a further elliptical trajectory around the Earth to a more circular trajectory around the Earth. Now the next phase you see in this picture is effectively the attempt from the craft to reach a perfect circular orbit around the Moon by further reducing its speed using its thrusters to get into a stable orbit, which was about, in this particular case, way outside the GTO area. We're talking about 115,000 kilometers away. Although a large amount of different orbits were generated, as you can see by these yellow marks, which is rather unusual, but the reason for it is for ISRO to achieve such a required orbit with the smallest amount of thrusters being used. So this validates an enormous amount of steps for ISRO to design a craft and capability to bring and return humans to and from the Moon. I must say this is really a great achievement from ISRO, so well done for that. December 1st, SpaceX launched the mission called 425 Project Flight 1 for the Korean Agency for Defense Development and the Korea Aerospace Research Institute on board of a Falcon 9 from its Space Launch Complex 4E in Vandenberg Space Force Base in California. The payloads are one reconnaissance satellite featuring an electro-optical infrared telescope, which will operate in low Earth orbit between 600 and 700 km, and an Irish CubeSat called ADITYA-L1, no surprise there on the name, carrying a gamma ray detector and an experiment of thermal coatings for other spacecraft. The remarkable thing here that it was made by students from 2 Irish universities, so there were 23 other spacecraft on board this mission, including Space BD's ISL-48, CETA-L micro headsat, D-Orbit's Ion SCV Daring Diego, York Space Systems Bain, and Planet IQ GNOME 4. The booster landed back in Vandenberg in Landing Zone 4 for his 17th time. It was the 90th SpaceX launch in 2023 and SpaceX 250th successful first stage landing. What a feast, what an achievement. December 3rd, SpaceX launched another Starlink batch of 23 V2 minis for his mission called Group 631, atop a Falcon 9 out of his Space Launch Complex 40 from Cape Canaveral Space Force Station in Florida. The payload was successfully placed at 530 km circular low Earth orbit and 43-degree inclination. The first stage landed on the drone ship a short fall of gravitas for its 6th time. Monday 4th of December, a Long March 2C was sent in low Earth orbit by China Aerospace Science and Technology Corporation from its Huaquan Satellite Launch Center in China. The first payload was the MISRSAT-2 satellite, meaning Egypt 2, a small remote sensing satellite that will be operated by the Egyptian Space Agency. The other payload was the second batch of Starpool-1 satellites, independently developed by Ellipse Space Technology Corporation Limited, with an expected constellation of 100 satellites for Internet, sat-nav systems providing positioning, navigation and timing, as well as Internet of Things and Earth observations. On the same day, South Korea successfully launched a solid-fueled space rocket for the Agency for Defense Development out of its sea launch platform 4 km or 2.4 miles south of Jeju Island in South Korea. The payload was a small 100 kg or about 220 pounds synthetic aperture radar observation satellite in low Earth orbit at 650 km altitude. The rocket is made of 4 stages, with solid fuel powering the first 3 stages and liquid fuel on the 4th one. It's the 3rd launch of such a rocket. December 5th, Galactic Energy has resumed its CRS-1 launches after its last failure on 21st of September this year. The fault was due to abnormal ablation of the first stage nozzle's diverging section. Analysis found improper operation manufacturing some screw holes caused defects in carbon cloth layer. The CRS-1 rocket has carried the Tianyang 16 and Starpool 014A satellites to low Earth orbit from its Huaquan Satellite Launch Center in China, with its mission name We Won't Stop. Good to see the rocket back in action. On the same day, China Aerospace Science and Technology Corporation sent a Smart Dragon 3 from its sea launch pad off the coast of Yangyang, Guangdong Province in China, with a satellite internet technology test satellite on board. The Smart Dragon 3 is a new solid propellant rocket developed by the China Rocket Corporation Limited. The launch was coordinated by the Taiwan Satellite Launch Center and was its second flight. December 7th, SpaceX launched 23 Starlink V2 mini satellites to circular low Earth orbit at 530 km altitude, 43-degree inclination, for its mission Group 633 on board of Falcon 9 Block 5 from its Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. The first stage landed 612 km downrange on the drone ship. Just read the instructions for its 9th time. December 8th, SpaceX launched 22 Starlink V2 mini satellites to circular low Earth orbit at 530 km altitude and 53-degree inclination for its mission Group 7-8. On board a Falcon 9 Block 5 from its Space Launch Complex 4E at Vandenberg Space Force Base in California. The first stage landed 642 km downrange on the drone ship Of Course I Still Love You for its 13th time. This week's image is the Lobster Nebula taken by the James Webb Space Telescope. This nebula is also called NGC 6357, not as sexy as Lobster Nebula, but anyhow known as the massive star-forming region in the constellation Scorpius. At a distance of 6,000 light-years from Earth, or 57 quadrillion kilometers or 34 quadrillion miles. A quadrillion is 10 at the power of 15, or basically 15 zeros. The nebula contains many protostars shielded by dark disks of gas and young stars wrapped in expanding cocoon and expanding gases surrounding these small stars. A protostar is a very young star that is still gathering mass from its parent molecular cloud. This nebula contains the most massive stars in the galaxy. Astronomers have identified the abundance of water, carbon monoxide, hydrogen cyanide, and acetylene, C2H2. All these are essential components in star formation. They also believe that planets' formation may be well underway or indeed have happened despite the extreme environment. Thank you for tuning in to your latest episode. I am Christophe Paget from Espace News to bring you space news understandable by the youngsters and of interest by the grown-ups. Have a great week. Goodbye.